This is part 2 of the J&J BSR battery spring return fail-safe plug and play system. There are no springs, mechanical springs in the system. We're merely providing an alternate power supply from an internal rechargeable battery. In the first video we showed you how to remove the cover to install the kit and replace the cover. In this video we're going to demonstrate the functionality of the fail-safe system. We've now got the actuator connected to an external power supply. We've got an open signal applied and the LED status light is lit solidly. We'll just drive the actuator into the closed position. The actuator operates, even with the battery system fitted, as a standard power open, power closed system under normal circumstances, and whilst it's operating as a normal power open, power closed system, it's recharging or trickle charging the internal battery to ensure that the internal battery is maintained at full capacity. A quick point on the battery is actually oversized for the application so that we can have a certain amount of degradation in the battery, but it will still work. Manufacturers recommend that the batteries are changed every 5 years or so. We haven't replaced many batteries in the last 14 or 15 years, and we've not been advised of any cases where the fail-safe system didn't function when it was required to, and we're absolutely sure that if a customer has a fail-safe system and it didn't operate when it was required to, we'd be the first people to know about it. So the battery is very reliable and very dependable, and we have 13 or 15 years experience of using this particular battery in applications all over the world. So we're very comfortable with the reliability of the batteries that we use. This actuator is configured to fail close on loss of external power. So if I drive it into the open position, then I actually remove the power supply when it gets half open, maybe now. So I've now removed the external power supply. The batteries have realised that there's no external power. It's switched over to draw power from the internal source of the battery, and it's set the actuator to the closed position, which is how it's configured. What's now happening is the LED light is blinking to show that it's under battery operation, so there's just a very slow blink, and after 3 minutes or so that will stop, and otherwise we'll just drain the battery, flashing the light. When we reapply power, the actuator will respond to whatever signal is being applied when we reapply it, and as we haven't changed the command signal from the open signal when we lost power, as we reconnect power, the LED status light will now lock on and the actuator will drive. And again, if we were to lose power halfway through the stroke, exactly the same will happen. The LED will start blinking and the actuator will go into the closed position. We can configure this into the fail open position. There is a jump on the main circuit board that we can remove, and then the actuator will be energized close, fail open on loss of power. One point I can make is that you may have realised that there's a possibility to use the actuator similar to a solenoid, whereby you would have a 2-wire energized system battery fail. That's true, you can use the actuator that way. It's not designed to do it, and of course whenever the power is killed, whenever you've lost mains power, then we lose the benefit of having the anti-condensation heater, and because we provide the anti-condensation heater as standard and it works whenever power is applied, if an actuator was damaged because of condensation, it wouldn't be covered under the warranty. You just need to be aware of that point. But on the basis that the condensation thing isn't going to be an issue for you when the power's out, then you could wire this DIN plug, this main power DIN plug, with just a 2-wire system, so that in this case, where it's fail closed, you would have a 2-wire energized open system. Whenever the power was lost to those 2 pins, then the actuator would go into the closed position, so effectively we're working like a solenoid. The main condition of the 2 conditions, the first one is the loss of the anti-condensation heater when there's no power, but the second one is that you must replace the charge that you take from the battery whenever you've had a closed operation, or when you've had a power under battery operation. And the minimum recharge time for a Model 20, which is the shortest recharge time because it's the lowest torque output that we have, is around 30 minutes. So after every power operation, every power out, then you must recharge, so the energized time, the following energized time, must respect a minimum, in this case, of 30 minutes. On the larger actuators it's more than an hour, I can't remember the exact details with me. But in this particular one we're talking about a 30-minute recharge time. So, as you can see, the BSR, the battery spring return, that there are no springs, it's a rechargeable battery, is a very user-friendly, simple to install, cost-effective way of providing fail-safe electric actuator functionality. Thank you for watching the video. Please look at the other videos that we have. There are many videos on the site that cover all the different aspects, all the functions and all the features of the J3 and the J&J electric actuators. Thank you for watching the video.